Greetings and welcome. In this session, we will see the procedure for HVAC cooling load calculation for case 2, that is a mixing after cooling coil. Objectives of this video session are: we will see the procedure for location of outdoor and indoor condition of air. After that, before and after mixing chamber, the condition of air will be obtained. How to determine dehumidified air quantity and its two parts, fresh air and recirculated air quantity, that we will see. After that, we will see the procedure to find the room sensibility factor, grand sensibility factor, and effective room sensible heat factor. And finally, we will see how to determine capacity of cooling coil. In the first objective, that is location of outdoor and indoor condition of air, we need a block diagram of the process. This is a block diagram of air handling unit. This is a part of central air conditioning system where the outside and recirculated air both are mixed. So here if you see, from the outside air is taken, that air is passed over the cooling coil. So this is a process air. This process air is mixed with the return air, and the sum of these two, that is called as dehumidified air, that is passing to the hall to receive the heat content from the hall. Now in this case, in a given data, outside air condition in the terms of drivable temperature and RH, also for indoor condition space, drivable temperature and RH. By using this data, we locate point O and point I. So here on the psychrometric chart you can see this is a point O, that is a condition of outdoor air, and point I, that is a condition of indoor air. In the numerical, dew point temperature means cooling coil surface temperature is given, that is also called as apparatus dew point. So that apparatus dew point is situated on the saturated line, that is relative humidity line of 100%. After that we join this point O to ODP. Now here this O and I, from these 2 points we produce here triangle. Means to this OI line we draw horizontal line and we draw vertical line. Intersection of both line we find point A. Then we produce the enthalpies of outdoor air, indoor air, and this third point intersection on the enthalpy scale, which we use in further process. Next step is to find the room sensibility factor. For that we use the formula room sensibility factor is equal to room sensible heat divided by room sensible plus room latent heat. By obtaining this factor, here is a scale of sensibility factor which is ranging from 0.35 to 1 in downward direction. So the said value we locate here on this scale with the name B. Point A is a combination of 26 degrees Celsius drivable temperature and 50% RH, which is called as alignment circle. This is a reference point we plot on the psychrometric chart. Then we join point A and point B. Thus we get this AB line, that is a reference line to draw room sensibility factor line in the next step. So here we have this line AB here, blue color line. To this line we draw a parallel line through point I up to saturation line. This is a blue color line. So this line is called as room sensibility factor line. Then here this blue color line and this red color line are intersected and we get point number 1. So this point number 1 is a condition of air leaving the cooling coil, means here. After the cooling coil, this is a point number 1. But this is again before mixing chamber. So condition of this point, after getting on the chart, we find the values, properties of this point. Dryable temperature TD1, enthalpy H1 and relative humidity phi1. So that we mention over here. So this was about condition of air before mixing. Now after mixing, that is point number 2 that we will see in next slide. Here we need percentage of fresh air, means outside air, and percentage of return air or recirculated air from the given data. Now what line we are using, that is already drawn, that is RSHF line, blue color line, I1, this line. So we have to measure length of this I1 line. On this line we have to locate point number 2, that is a condition of air after mixing this. Now how to locate? So for that purpose, this 1 to I line is shown here again. So here fresh air which is coming from the outside and is passing over the cooling coil, and it is coming at point number 1. So this fresh air content percentage is shown on the opposite side with this distance, that is 2I. So that is why point number 2 can be located by using the formula, that is length I2 will be equal to percentage of fresh air given multiplied by this total length I1. Thus we find the point number 2 on the chart. After that, by projecting from this point in a different direction lines, we find here dryable temperature TD2. We find here enthalpy, on enthalpy scale enthalpy H2, and here curve we find the relative humidity. So these are the condition of air after mixing and which is entering to the hall. After getting this point number 2 and corresponding enthalpy H2, that is H2. So here we use this enthalpy and I enthalpy in the determination of dehumidified air quantity. Now dehumidified air quantity means what? The air, outside air which is passing over the cooling coil and it is mixing in a mixing chamber with return air, summation of these both air which is passing to the hall, this is called as dehumidified air. So this dehumidified air at point number 2, that is why its enthalpy will be H2. So this is a cold air which is shown here. When it is passing to the hall, it will receive the heat from the hall in the form of RSH and RLH. Thus its enthalpy will be increased, which is coming out as a return air. So this enthalpy is increasing, means this is what enthalpy difference, that is in the form of HI and H2, HI to H2. This enthalpy difference from the enthalpy scale we find, and then we use that here to find dehumidified air. So formula for room total heat means heat content in the hall, that is room sensible heat plus room latent heat, will be equal to what? Amount of air, that is m dot d, passing to the hall, multiplied by enthalpy difference between entering air and leaving air, the hall, that is HI minus H2. Now HI is a higher enthalpy, that is why HI minus H2 comes. So this RTH formula is in kilowatt. So from this formula we find dehumidified air. This dehumidified air is a total air. This air has two parts. One is a fresh air percentage in the data given and return air percentage data given. So by using this percentage we can find the fresh air quantity, means MO, means outside air, by multiplying fresh air percentage with dehumidified air quantity in kilogram per second. Similarly recirculated air, means return air quantity in kg per second we find by multiplying percentage of return air with dehumidified air quantity. Thus we find here three quantities of air: dehumidified air, fresh air and return air. Now in grand sensibility factor calculation we use the formula of RSHF and we consider in that formula outside heat content, which has two parts: outside air sensibility, outside air latent heat. So formula becomes RSH plus OASH at the numerator divided by at the denominator same bracket, and this second bracket is room latent heat plus outside air latent heat. Now this outside air sensibility and outside air latent heat, how to find? So for that purpose, the diagram which already we have drawn, triangle OAI, this triangle is shown here. So here this horizontal enthalpy difference A to I, HA minus HI, this is what sensibility, multiplied by outside air M dot O will be what? OASH in kilowatt. Vertical difference, that is HO minus HA multiplied by outside air comes in kilowatt, outside air latent heat. Then this corresponding outside air sensibility is added to RSH. We get GSH, means grand sensibility, and room latent heat plus OALH, outside air latent heat, that becomes grand latent heat. Summation of these two, that becomes grand total heat in a kilowatt. So in this way, we, after obtaining these OASH, OALH value, we put here in the formula, we find the grand sensibility factor. This grand sensibility factor, similarly like room sensibility factor, we locate on the sensibility factor scale. So here we use point C to locate GSHF. Then we join A, that is alignment circle point, and C. Thus we get this red color line, AC. Now this AC line should be parallel with this O-ADP line. So this O to ADP line is called as grand sensible heat factor line. After that, effective room sensibility factor line. In that, the formula of grand sensibility factor, addition to that, here bypass factor comes in picture. So here outside air sensibility is multiplied with bypass factor, numerator and denominator. Also here outside air latent heat is multiplied with bypass factor. Now we will see about the bypass factor. Now here we can see this is a process, O to ADP. On this is a point number 1 which comes, that is a point number 1 before mixing coil. So here this is a coil temperature and this is a obtained temperature. Thus we find this inefficiency of the coil. So here this difference, that is TD1 minus ADP divided by this total difference, means TDO minus ADP. This is called as bypass factor of the cooling coil. Then we putting this bypass factor value here, we find ERSHF. That ERSHF we locate with letter D on the scale. Again we join alignment circle A and D. Thus we find this line, brown color line. Now this line should be parallel to the line which is drawn here through point I and ADP. Means here we join I and ADP point, this brown color line. So these both lines should be parallel to each other. So we call this I to ADP line as a effective room sensible heat factor line. Now next step is capacity of cooling coil. Now cooling coil is situated here before mixing. Across the cooling coil, if you see, this is a point O, that is outside air. This is a point 1, that is after cooling coil. Means during the cooling coil or during the cooling process, what the enthalpy of air is absorbed by the refrigerant, That is called as cooling coil capacity. How to find that? Here mass flow rate, which is passing over the cooling coil, that is m dot O, multiplied by enthalpy difference from HO to H1, means HO minus H1. So this capacity we find in kilowatt. After that, we can convert this kilowatt value by dividing it with 3.517. Thus we get capacity of cooling coil in terms of refrigeration, means TR. So here if you see as a summary, we obtain the procedure to locate outdoor and indoor condition by given data, that is point O and I. Then also we studied how to locate condition of air before and after mixing the chamber, that is point number 1 and 2. After that we saw the procedure to find dehumidified air quantity and its two parts is fresh air and recirculated air. And lastly we saw the procedure for room sensibility factor, grand sensibility factor, effective room sensibility factor, and capacity of cooling coil. Let us meet in the next video session. Thank you.